the world of microorganisms, where no matter how small you are, you're still important. Oops, sorry, wrong world, graphics malfunction. Correct version loading in 3, 2, 1. There we go, that's more like it. Of course, all of them aren't green though. In fact, they come in many colors, sizes, and with different qualities too. They're also quite useful to us. Coming to the main topic for today's discussion. Drumroll please. How do microorganisms contribute to sustainability? Both sides. Introducing bioremediation. What is bioremediation? The use of naturally occurring or deliberately introduced microorganisms to break down pollutants and clean polluted sites. How does it work? Unlike harmful pathogens, beneficial microbes break down pollutants and clean water and soil, helping nature to recover naturally. Any real-life examples? Bioremediation used microbes to clean London's Olympic Park in 2012, turning a toxic site sustainable. Next up, pathogen dynamics. What are pathogen dynamics? Pathogen dynamics studies how viruses, bacteria, parasites, and fungi spread, evolve, and persist in hosts and environments. What effect does it have? Infectious microbes severely disrupt systems, harming crops, livestock, wildlife, and triggering crises like COVID-19. Why are outbreaks increasing? Human activities like deforestation and overuse of antibiotics speed microbial evolution, causing more spillovers and rising antimicrobial resistance. What are some further cascading impacts? Pathogen outbreaks strain economies and health systems, as seen with COVID-19 diverting trillions from global sustainability goals. Moving on, comparative study. Microorganisms, friend or foe. This table compares bioremediation and pathogen dynamics in the aspect of core concepts, key microorganisms, and possible locations. This part compares their natural role, human impact, and experimental focus. This section talks about possible variables to test, expected observations, and safety considerations. And this area elaborates on sustainability connection, current research link, and broader impacts. Finally, the experimental analysis. What was our aim? To study pathogen-host interactions and compare bioremediation agents in reducing oil pollution. What was our hypothesis? Natural agents will reduce oil pollution better than the control. What were our methods? Pathogen model. Cheek cells were treated with food coloring and observed under a microscope to simulate interaction. Bioremediation. 4 containers with samples were set up with equal water, soil, and oil and observed for 5 days. What were our results? Dye cluster around cheek cells simulating pathogen attachment. Oil reduction. Saliva 90%, clay 70%, duckweed 10%, control 2%. Now some science is happening here, shots. Conclusion. The experiment showed saliva removed the most oil, followed by clay and duckweed, while the control showed little change, supporting effective bioremediation for oil spills.